I'm going to be talking about some related, but maybe we'll have to stitch them together topics: patient matching, informatics, and data science. I want to talk about examples and perspective for the future. I'm going to be talking about some research results, but I'm also going to be talking about sort of strategically where we are going and what we need to be successful. So first of all, I want to talk a little bit about me, patient matching, informatics and collaboration, and then the future. So part of the reason I want to talk about me, and we'll get to this in collaboration, is I think, we want to see more cross-center collaboration. And I think cross-center collaboration requires, it's about developing new relationships, and relationships are best developed when people know one another. And so I hope that, and I've realized that I know a lot about many of you and your work, but I don't know, outside of CBMI, I don't necessarily know a lot about people. So I'm going to try to start breaking that down. So this is my family. This is my son, Isaac, on the left. He's 16, almost 17. He started driver's training, and it's freaking us out. My beautiful daughter, Selah, for whom and my younger daughter, Lydia, I've already purchased the shotgun. And my lovely wife, Sherry, who is a family physician like me, and I live vicariously through her clinical work. And I get to hear all the time about how EHRs are failing us. That's great to have. So I view myself, my priorities are to be an excellent, to the extent I can, husband, father, and change agent, in that order. I think all of us are here to make change and impact on the world. One other fun fact about me, I love the author C.S. Lewis, and one of my favorite quotes by C.S. Lewis is, "You don't have a soul. You have a body. You are a soul." So think about that for a little bit. So there, that's me. So now I'm going to start with going into the research. So this may be, and for those of you who saw this at the Fall AMIA presentation, you can't answer. So this may be the greatest contribution I make to my field in my career. You ready? So what do we call a resigned, long-suffering fire starter? Anyone? 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 A patient match. And you can see here, just you wait, I'm going to light that fire once time is up. So I created the dad joke for patient matching. So that may be my greatest contribution, but anyways, so I've checked the box of telling a joke at the beginning of the talk, so now we can move on. So moving into patient matching, I do want to talk briefly as an example of the kind of work that we're doing. I want to talk about patient matching. We all know that we don't have a national patient ID here in the US. We're the last developed country not to have one. So we use a lot of algorithms. We use a lot of ad hoc approaches to integrating our data. There isn't a lot of evidence-based best practice guidelines out there, what works well and what doesn't. And so because of that lack of consistent approaches, there have been a lot of expert panels that have been put together. So we've had ONC and AHRQ put out a white paper. HIMSS made some policy recommendations. The eHealth Initiative made some recommendations regarding patient matching. The Bipartisan Policy Center made some recommendations regarding patient matching. The Sequoia Project has created a framework for patient matching. And most recently, ONC again convened an expert panel to provide expert-based guidelines. Everybody in every one of those panels, people have said, it makes sense to us if we standardize the data, matching may be more accurate, more effective. Nobody's proven that point. Now, seems obvious, but the question really is more than just, does standardization help? Does cleaning up the data help? But which efforts would help? So do we standardize all data elements for matching, just some? What should we do here? So Pew, the Pew Charitable Trust, about 2.5 years ago, initiated a health IT division And so they're beginning to do some work in the health space to advance policy. And one of the areas they recognize as a huge challenge is patient matching, because we don't have consistent methods for doing it. So they came to us and said, hey, why don't you guys, using your rich laboratory with the Health Information Exchange, why don't you help us evaluate some of these standardization recommendations? So a lot of details. I'm just going to run through at a high level. We identified recommendations for standardizing last name, telephone, address, social security number, and birth date. And so we implemented those standardizations. We looked at standardizing each field individually. We looked at standardizing fields in different combinations to see which worked. That was essentially our analysis, fairly straightforward. As we all know, dealing with real world data, it's not straightforward. So we had to clean up the data and figure out why we were seeing strange things. But eventually we put together about 138 different data sets to look at all the possible combinations. And here's what we found, digesting it down to its basics. So last name and address, those were the fields that actually showed some bang for the buck. And what this slide shows for sensitivity, positive predictive value, and overall accuracy, on the left-hand slide, the none column is when no standardization is applied. Last name only is, as it implies, only standardizing last name. Address only, and then address and last name. And what was interesting was the combination of the standardization actually was synergistic. It wasn't just the sum of the accuracies that you see alone. We actually saw improved sensitivity, improved overall accuracy. Now, I don't necessarily want to spend a lot of time. Clearly, positive predictive value went down, so we introduced some false positives. There are ways of dealing with false positives that we know how to deal with them, so we can actually correct for false positives, but finding those new matches is really important. If you recognize that there are about 20 billion, at least, low-end estimate, at least 20 billion transactions exchanged in the US every day. If you even see, if we go from 82% sensitivity up to 92%, we've just eliminated 50% of the missed matches. And if you interpolate that up to the all transactions in the US, you're finding about on the order of 2 billion more transactions are matched accurately. So that's important. And so where do we go with this? Well, we're working with ONC and other policymakers right now. We're even talking with Senator Elizabeth Warren's office right now. She's very interested in health IT policy, and patient matching is something of interest to her. We think that we should be recommending to EHR vendors that they begin standardizing the data before they match. And it needs to be everybody. If we want to maximize accuracy, it can't just be one side standardizing. That'll show some improvement. But if you do both sides, you're going to see the maximum amount of improvement in matching. So I bring up patient matching today. Number one, it's near and dear to my heart. It's interesting. Why is it interesting to me? Because I think it tells the textbook case for what informaticians do. We see a problem. The problem here is patient matching is not done well. We developed some solutions, and in this case, they're pretty cool technical solutions. I could go into the hill climbing algorithms that we use to standardize the values and all sorts of cool things that Huiping Zhu and Xiaochun Li are doing to create new algorithms. Really cool technically, really important problem. We got to do the study, we make some important discoveries, and once we have positive findings, those often have policy implications for healthcare. And that's the fun spectrum in informatics. If you are a person who, as a biomedical informatician, is interested in medicine, is interested in technology, and interested in changing the industry and making a positive impact, it's a great field to be in. And I think this is a great example of what we do. So, biomedical informatics. We identify important system information and analytical challenges that hinder positive health outcomes, care delivery, and innovation. That's kind of a summarize from the American Medical Informatics Association. So here are some of the challenges that we've addressed in the Center for Biomedical Informatics over the years. How do we maximize the accuracy and efficiency of patient matching? How do we accurately and efficiently identify families in EHR data? This is a really cool story, and this is why understanding the data, that lifeblood through health systems, is so important and can lead to some really interesting solutions. So Nick Tatanetti out at Columbia University wanted to look at inheritance patterns, wanted to see what diseases would be inherited from parents to children. Well, finding parental-child linkages, familial linkages, sometimes hard, and often you have to do backflips to find those linkages. Columbia came up with a brilliant approach, and when I heard it, gosh, I wish I would. So it turns out that when people go to the hospital, often they give an emergency contact number, right? Families generally can be linked through their emergency contact numbers. And using this approach, the Columbia folks were able to create an excellent analysis, just looking through EHR data of what diseases seem to be inherited from parent to children. So that's an example of somebody understanding the workflow of a health system, understanding the kind of data that's there, and then understanding what you can do with it. So I just think that's a beautiful, simple example. How do we scale and sustain public health surveillance? Brian Dixon and I'll be bombastic. I think we helped to create the field of public health informatics here at Regenstrief, and Brian is leading that area. We've created the largest and longest running notifiable condition detector, finding notifiable diseases. We've also created the longest running and largest syndromic surveillance system in the country. And we did that by building systems that didn't burden providers, that leveraged data that was already there, only asking for more data to achieve our goal if we couldn't achieve our goal or some proxy for that goal. And so there's a lot of strategy in addition to the technology as we think through this. Integrating, standardizing, and sharing clinical data, that's health information exchange. And we continue to do that work in helping developing countries think about how can they, using their very scarce, limited resources, build their own e-health infrastructures. These are some of the important questions that we're answering right now. And one of the keys in informatics, which is really cool, and it got me promoted when I put this in my promotion and tenure document, was the solutions that we build, the systems that we create to solve a problem, then become our laboratory. So our notifiable condition detector, our syndromic surveillance systems, we built those for the state health department, but then they've become a laboratory for research and innovation. Very similarly, we did that with the EHR, the Gopher at Eskenazi. That was solving a problem that became a laboratory. And so we're always thinking about when we do research,
if you want to bring that back to her,
how can we leverage that, not only to solve the problem and maybe answer a clinical question, but there's also an opportunity with just about any research project, because it uses data, and typically data, there's technology behind that data, there's almost always an opportunity to answer informatics questions. And so I would encourage us to think about how we can, as a institute, advance both the clinical and the informatics state of art.
Okay, that's good.
So this is, I always think in 2x2 tables, and I have to put my 2x2 table in the talk. A simple framework for collaboration. I've modified this for other. So there are clinical and health innovations. There are informatics innovations. They're often related. If there is, the negative means no. So if there's no real new clinical innovation, no real new informatics innovation, that might be a quality improvement project. That's still important, it's still useful. We might bring to bear existing knowledge in both domains to make a difference. You generally won't get a grant out of that or work with an external industry to get that done, because it's kind of bread and butter work. But if we then start thinking about, is there a clinical innovation? Are we going to advance the state of the art for care, for population health? Not necessarily any informatics innovation, though I would, as I said in the previous slide, I would argue that there's probably a way to find one. That's good and probably fundable. I mean, we lots of health services researchers not focused in informatics get a lot of grants in this space. On the other side, for informaticians, we might come up with a cool new way to match patients, but we're doing it to support a care process or a population health question that's already been answered. It's a novel methodology, a novel approach. Again, also likely fundable. But where I think we can knock it out of the park and where I think Regenstrief has capabilities and resources yet to be leveraged is when we bring both of these together. And we have the ability to do that here. And I hope that through things like the cross-center collaborations and other work, that we continue to think more and more about how can we not only be a leader in health and health outcomes, but continue to be a leader in informatics innovation as well. And in fact, it's a great book, Scaling Up Excellence, talks about how organizations sort of hit a barrier. Once you become successful in certain areas, you get into these pockets of excellence. For those technical people in the crowd, hill climbing algorithms search for a maximum point in the data. I think Regenstrief, in some sense, in many senses, we're doing awesome, amazing work, but in some sense, we're stuck on local maxima. We haven't found the maximum point for us. And organizations get stuck in local pockets of excellence. And I think there's an opportunity, again, by looking for new ways to achieve excellence by combining our skills. Science is a team sport. We all know that. It's become a team sport. And so I think there's a lot of opportunity here to think about how we can do that, both from the science, from the technology, from the health, and also from the organizational perspective. So that's my advocacy on collaboration. So how do we get to that upper left? Obviously, I think we want to continue strengthening the Regenstrief collaborative environment, whether structurally, organizationally, through incentivizing these collaborations. I think there's lots of ways, and that book that I mentioned talks a bit about that as well. The health and clinical domain experts, the folks across the top of that 2x2 table, there's a lot more to do there, but I'm focused on informatics, so that's why the informatics list is much longer. But obviously, continuing to identify priority health problems and challenges that need to be solved is going to be important for us to make it to that upper left quadrant. And then in informatics, what do I think we need to be doing? Where do we need to be focusing some of our energy? We need to increase the depth, breadth, and quality of our data assets. We know that we need to do that. We know that there are issues there that we need to improve. We need to make those data assets more available, accessible, secure, and get them out in a more timely fashion. We need to provide tools and infrastructure to innovate more effectively and efficiently. Not only do you need data, you need the infrastructure, the people, the processes, technology to actually get value, get innovation out of that data. And I think we need to improve that as well. I will put in an advertisement here. The week of April 24th, we are having the leaders of a particular analytical community called Odyssey visit us. The Odyssey organization has built a platform for data sharing and data analytics. We think it could be an important part of our future infrastructure here. We're also going to have a data hackathon during that time. It's going to be Wednesday of that week, and we're going to start in the afternoon and go well into the evening. More details to come. We'll provide dinner and snacks. So we'll have a day of data hackathoning, and then the next morning we will have report outs on what we've done with the Odyssey infrastructure analytics. And many of you have heard about MD Clone, a tool to synthesize our data, take real data and turn it into synthetic data. That also can leverage the Odyssey infrastructure. So I think we're going to be making some additional explorations there as well. So stay tuned on that front. And then of course, I said people, processes, and technology. We need the people. I believe that we need not only data science and data analytics faculty, I think we also need that capability and capacity in the staff as well. So I think we need to work on that as well. So that's how we, with a focus on informatics, how we get to the upper left. So I'm going to leave us with a view of the future. So there's lots of graphs out here like this, the increasing breakneck pace for innovation. This just shows us sort of some of the early technologies and how even this is out of date, right? So we now have a lot of machine learning algorithms that do as well as physicians in diagnosing and identifying certain conditions. Image recognition tools are growing. But the point of this is technology is advancing rapidly. What this doesn't make clear, though, is the fact that because we have much more robust networking, data capture tools, storage devices, and computational power, we are experiencing a deluge in healthcare data. One of the most interesting things, and I think this is a conundrum right now, the amount of data that we are generating in healthcare, it's not clear by 2020 whether we'll have the storage infrastructure to keep all of that data. So we're generating a ton of data now electronically, and it may be the case that the data storage capabilities of the world may not keep up with the rate at which we're generating data. So we may have to start prioritizing that. I think it'll be very interesting to watch the data storage space and what happens there, because our storage capabilities right now are up here, our data generation, and we may cross this point, and that which may lead to some interesting issues. But we've got a ton of data now. And so because of this growth, one of the things that I've been telling our faculty, and you've heard me say it here before, whatever your goals are professionally to make an impact on the world, if you're going to build a new tool, if you're going to create a new clinical intervention, just presume you have the data, because in 5 years, 7 years, you will. The data is going to be there. And so start building the tools and infrastructures and capabilities now to catch up to this. I think it's going to be really important to be thinking about that. So the data is growing, and man, what can we do with that data? So now the challenges that I think we face in informatics. There is an emerging initiative that recognizes the following. 10 years ago, everybody was trying to get their own pile of data. We now know everyone's got piles of data. Now, everyone's trying to create their own algorithms. They're trying to do stuff with the data. We've done a reasonable job of beginning to standardize healthcare data. We have not done, there hasn't been a ton of work in standardizing the metadata, the algorithms, the characteristics of this data. How do we know how to exchange data well? How do we exchange algorithms? How do we exchange characteristics of this data? It's going to be really important, because as we move forward, we already are seeing it. There's an explosion of algorithms, of approaches, of methods. And how do we know which ones work well and which ones don't? The computable biomedical knowledge movement, I think, is important. I don't know exactly where it's going to go, but in that space, this is one of those instances where you know it's going to be important, but you're not quite sure how, but you should be involved in it, because we can just look at what's happening. The data is growing, the analytics are growing. How are we going to manage that? And so creating standardized approaches. Regenstrief knows a lot about standards, and I think there's opportunities in that space. One other question I put in here, the generalizability of algorithms. Some of the work that Saranga and one of our interns from Purdue, Gregory Dexter, have done is shown that algorithms that when we create algorithms based on the entire data set from the Health Information Exchange, the algorithm does the best. If you hold out a particular institution's data, train the algorithm, and then try to run that algorithm on that institution, the algorithms don't work as well. So if you want to do population health, healthcare analytics, you've got to see the data for the population. You've got to see the data for that particular circumstances. That's one of the requirements of these algorithms. So the question is, how generalizable will Indiana's algorithms be to Kentucky, to Arizona, to Massachusetts? That's an open question. And we need to make our algorithms generalizable, because we can't have thousands, tens of thousands of algorithms doing the same thing. We need consistency in our output. How do we manage unstructured data? Still, 80% of the data that we capture electronically is unstructured. We need tools and techniques, better tools and techniques to tackle that. How do we incorporate the non-traditional data? We're going to be hearing about the Addictions Data Commons and how we're gathering non-traditional data to support research. And then what are the implications of and best approaches for managing patient-gathered and patient-controlled data? These are all incredibly open fields for research and innovation. So, does anybody know what this is? It's a schematic for a DNA microchip where you have different probes for different genetic variants. I believe that the DNA chip of the future is data collection. So data collections are the DNA of communities and systems of care. And in order to understand what this data tells us, in the same way we're figuring out how to tell what genes tell us about ourselves, we need to figure out ways to tell us what the data tells us about systems. The data is getting so complicated that we're going to start needing analytical probes, analytical methods to get at this stuff. Because it's not, so I could imagine here, I've got different clinical outcomes or diseases across the top, and I'm going to try different algorithms across the bottom and just do a ton of variations. But it's not just a 2x2. The variations, the dimensionality of this space is huge. So it's not just diseases and algorithms. You're looking at different segments of the care process. Do you want to do pre-disease analytics? Do you want to do post-disease analytics? Do you want to look at cohorts, risk factors? There's so many different types of information at different segments of the data population that we need that we have to think about this in huge dimensionality. Nobody has solved this problem, and this problem's going to get harder because we're going to have more and more data. And by the way, everybody's just creating their own algorithms at this point. I might know what one of those red dots mean in my data, but if I run an algorithm on somebody else's data, I don't know that I can trust what it means. This is the world we're moving into, and this is where informatics can play a very important role. So, what does wild success look like? This is very high level, and I can go into a lot of details, and maybe folks will have questions, but this is what I think. From my perspective, for me as a leader in informatics at Regenstrief, I think of two dimensions. Number one, I think about the fact that informatics is an enabling, a supporting discipline. It's also an innovative discipline, but there's support that needs to be provided. So I want to see research, service, and translational stakeholder needs supported and met in exceptional ways by deeper, broader, more accessible data, flexible, fast, leading-edge tools for extracting value from that data, and a growing community of informaticians, data analysts, and scientists to lead the way, it should have said. And multiple novel, so personally, multiple novel data extraction methods. Why did I say data value extraction methods there? Because the current push and excitement in machine learning, artificial intelligence, they're just tools to get value out of the data. Logistic regression and statistical summaries of decades ago are the same kinds of tools. We're trying to get new knowledge, new discoveries, new innovation out of the data, and we do those through different tools and techniques, of which AI and ML are currently the hot topics. But I want us to continue to innovate in these data value extraction methods. Natural language processing techniques are another one, and that we develop them, we study them, and we deploy them and prove that we can actually make a difference in health and healthcare. So with that, I will stop. I have a couple minutes for questions. Moaz.
As usual, thought-provoking and really cool, and simplicity, which I love. Like, it's all about this machine learning. It's just tool, man. It's like that. So that was really good. I loved it. I'm very interested in your, as usual, the 2x2 in that left corner things. So what kind of organizational structure we need to create that plus and that 2x2? For me, it reminds me of all the mistake I made 10 years ago, where I did not get the user perspective. So I published 3 clinical trials using computerized decision support. All of them were negative. and now I'm thinking, oh my gosh, if I just learned from behavioral economics, I will have set up the computerized decision support in a different way. So how can we, as a Regenstrief Institute, how can we go after that top left corner? Do we need to think like like a symphony thing, you know, like you have these big, deep thinker in informatics, but then we might need like a couple of people who speak 2 languages. One of them is healthcare innovation, clinical, and then we might have like 3 conductors. I don't know. I'm just thinking, how can we get
I think you're asking a very important question. That's why I sort of put it up here. I think we need to think about how we get there. What you've mentioned, I think, are some of the participants on the team, which is absolutely something we need to answer. I break it down into a couple of dimensions. There are going to be there's the domain expertise in the healthcare space. There's the domain expertise. I put informatics innovation in here, but there can be user experience innovation, which I would argue is at least partly an informatics domain. But I think it's understanding what are the disciplines that are necessary to make this. I think always, since Regenstrief's mission is to improve health and healthcare, I think there always needs to be that clinical domain expertise as part of the team. But then what are you trying to solve? Right? What are the skill sets necessary? Last fall, we put in, it was very exciting, Burke and Saranga participated with a psychiatrist who wanted to put together a data coordinating center for Alzheimer's disease, wasn't it? Yeah. You know, so the clinician recognized that increasingly the NIH is seeing the value of informatics and data management capabilities. And so this was Dr. Breyer, Alan Breyer, recognized this need, came to Regenstrief, and so I knew Burke understood systems, Saranga understands analytics and methodologies, both which were needed, put them on the team. So it's understanding those requirements and making sure that those requirements are met. Umberto.
So nice talk and very stimulating. My question is about data quality. So why don't you elaborate a little bit about the impact of data quality and what could we do to address that in an innovative way?
Sure. I was ready to answer the question until you said innovative. You know, so, you know, data quality is fitness for a particular purpose. So I always start there and I say, you know, beauty is in the eye of the beholder. So we know that our data could be more beautiful, right, for a lot of purposes. And data quality, you know, 2 of the typical measures is accuracy and completeness. We've got some ways to go on completeness. So we have gaps and holes in the data. And so how do we go after those gaps and those holes? I think historically, a lot of our data has come from the Health Information Exchange, and health systems have sent the data that they needed to get value out. And so health systems today think about value in a particular way. We all know the world is changing. We see how the world is changing. I think it's incumbent upon us. Maybe this is innovative to some, maybe not. I think we need to do a better job as thought leaders in the space to work with our clinical partners to say, hey, you're not giving us this data. Let me tell you why it's important for us to have that data so we can add value to you, so that we work together and do great things, whether it's improving their operations or whether it's doing innovation and develop reputationally. I think we need to begin working more deliberately on those relationships and educating the community on that. So that will get to completeness. Accuracy, you know, that's a broader topic, and I don't know that I would go into more, but let's talk more later, but that at a high level, that's how I think about it. And you know, work has already begun. Jeremy Harper has led an initiative to do a very deep dive on our current data, and he's done a great job of identifying opportunities for improvement, and we're prioritizing those and working with our Health Information Exchange partners and clinical partners to start working on that. So more to come. And I think we're over time here, so. Thank you.